It is great to have everyone here. Today we're going to spend about an hour talking about what's new in .NET development. Before we start, I'd like to do a very quick survey. How many of you are C# developers? Can I see a quick show of hands? Okay. Hopefully I'm not going to point any fingers. Who's writing VB.NET code today? Okay. Still, there are a few folks writing. So today, one of the things that I'm a huge fan of is getting feedback. So I always put my personal email address on all my slides. So if I didn't cover something that you're interested in, or if you have follow-up questions, please. The best way to get in touch with me is send me an email, and I'll be more than happy to follow up with you later. Before we start, I want to set the context for our conversation today. I personally could have never imagined the huge success of .NET. In fact, when I speak to developers and customers and I ask them, what do you think .NET is? I get a tremendous variety of answers, everything from ASP.NET, Azure, WPF, and I think what's happened is .NET has truly taken a life on its own. And that's why when I kind of try and explain .NET to my mom or dad, for example, I try and explain it in very, very simple terms, in that .NET is essentially made up of a runtime, a set of libraries, which we call the framework, a set of languages, VB, C#, F#, and so on, as well as a set of tools. And what you've seen over the years is that some of these parts have evolved at different rates, right? For example, the ASP.NET team has been doing an amazing job evolving .NET for the web customers. And then on the tool side, with the S releases year after year, there's been a tremendous amount of innovation. So today I'm going to cover a gamut of things, including tools, the runtime, as well as the libraries as well. And as I mentioned, if I didn't cover something, please, I'll be more than happy to follow. Let's quickly touch base on what we've actually already done. I think it was around 10 months ago that .NET 4.5 was released, and you're all probably wondering, wow, this is the first time ever that you've released .NET or are about to release .NET again in the past year or so. And the one thing I really want to emphasize here is that with .NET 4.5.1, I want to think of the value that it provides is accumulative, right? So you have all this great goodness. Async in my mind is truly a paradigm shift of how I think about developers writing applications. We did a tremendous amount of work in the runtime and GC and G as well, where by you just upgrading to .NET 4.5, your application gets better. And that's the theme that we're going to continue on forward, is that we'd like our customers and developers to do as little work as possible when they upgrade to a new framework or runtime, but the apps just magically get better because we've done all this work under the covers. And so what this has resulted in is that the latest numbers that we have is that .NET 4.5 is installed on over 100 million PCs already. So within 10 months, we've had a pretty strong penetration rate, considering some of you have most likely noticed is that .NET 4.5.1 is actually not on Windows Update. So if you think about the adoption rate without Windows Update, it's still a pretty incredible achievement. And I'm sure some of you might be wondering, when is .NET 4.5 or 4.5.1 getting on Windows Update? And I can tell you that we are working on this problem as we speak. So this is those two are the context slides for today's presentation. Now, let's switch to what we're actually going to cover today. We're going to talk about three key topics, which are around developer activity, application performance, and this thing that we're calling continuous innovation or continuous delivery. And I'll touch base on exactly what those things are. But let's switch over to the topic that's near and dear to me, and that is developer productivity. Some of you might have remembered, if you're an old-time Visual Studio user, that in 2005 we introduced or we brought back a little feature called Edit and Continue, but there was something missing. In fact, if you go to the forums on Chat Online, if you go to User Voice, our own forum on Visual Studio, Connect and so forth, everyone has been complaining about where is 64-bit support for Edit and Continue. And today I'd like to announce that in .NET 4.5.1 we are bringing Edit and Continue to 64-bit. So for those of you who have been missing 64-bit Edit and Continue, I hope it's going to be a great addition to improve your developer productivity going forward. Now, let's quickly touch base on what the experience looks like in case some of you actually have forgotten how to use it and continue, since you couldn't actually use it for 64-bit applications. So what I've got right here is a very simple console app, and I'm going to press F5. I'm going to step over, then I'm going to step into the calculate area method, and you'll notice that there's a bug here where I'm calculating the actual area with using a power of 4, and it should really be a power of 2. So with 64-bit and continuous 64-bit application, just as you expect for 32-bit application, I can simply change that number without stopping the debugger, and I can continue my debug session as we speak, and I'll get the right result. So the experience is just as what you have in 32-bit applications. Now, one thing I would like to mention is that for web projects, which we've gotten lots of requests that folks want 64-bit and continuous support for web projects, there are a couple of options that you have to keep in mind when wanting to use 64-bit with web projects. The first one is, this is especially true if you have migrated your projects to from previous builds, is that on your project properties, the enable Edit and Continue option needs to be on. Otherwise, Edit and Continue will not work, whether if it's a 32-bit or 64-bit process. The other thing to keep in mind is that you actually have to tell Visual Studio to use the 64-bit version of IRS Express. This is under your tools options and projects and solutions. Those are the two main features that you have to keep in mind when using 64-bit Edit and Continue for web applications. Okay. Now, as I mentioned, 64-bit Edit and Continue has been requested by many folks in the past, and it worked exactly the same as 32-bit applications. It works for WPF, web forms, WinForms, the store, as well as WPF, as well as ASP.NET web projects. As I said, you just need to enable Edit and Continue in the project properties. So now let's move on and go to the next set of requests that we've had, and it's been outstanding for a very long time. And this is the ability to see the return value of a method in the debugger. I think personally this is a very exciting feature. It's been there for VB as well as this is classic VB and C++ for a long time, but this is the ability to be able to see the return value in the actual debugger as you are stepping over your code. And so what will happen is, as you're stepping over your code in the debugger, in the orals window and in the immediate window, you can now see what was the method that we actually stepped over. So let's do a quick demo. And the thing that really excites me about this demo is the fact that now you can string together a set of scenarios that allow you to experiment with code in a much nicer way. So this is the exact same application that you saw a second ago. I'm going to start the debugger, hit the breakpoint. I'm going to switch over to the immediate window and also have the locals window open. I'm going to step over, and I'm going to step over again. And notice the return value of the method is now visible to me in the debugger, right? So what would you do today? You either introduce some kind of temporary variable in your method, or you have to step all the way out to see whether you got the right result or not, right? But which time was way too late. Especially if you have a string of functions on the same, let's say, assignment, it's really hard to see what was the actual return of each of the functions. But what's really cool, as I said, I can now really interact with my program in interesting ways. So I can type in return value, and it gives me the return value. I can introduce what we call an implicit variable in the debugger, so I can do something like, hey, double area equals return value. So I'm installing, assigning the return value, and I can do things like obviously query for return area. Now what's really cool here is once I've temporarily stored this variable, then I can continue my stepping. And once I'm back in the actual call site and I'm going to step over, I can do really interesting things like does surface area equals 4 times area, right? So it's really interesting because now you can essentially inspect and experiment with your application without having to change any code at all, and by being able to implicitly create these variables as your debugging application, you can kind of create a hypothesis and then experiment with your hypothesis and then continue debugging without having to actually change any state of your application at all. I think this is a very, very exciting feature that will make the whole productivity really shine in Visual Studio 2012. Okay. Can I see a show of hands, who in the audience is developing Windows Store applications today? Okay, that's really, really interesting data. So I'm going to then assume that the majority of the folks in the audience are building desktop applications using WPF or building web applications using MVC or web forms. Is that correct? Yes? Yes? Okay, all right. That's a very interesting data point. So I'm going to scan through this slide really fast, but one of the things that I want to mention here is that I get lots and lots of questions about what is .NET support for Windows Runtime. So for those of you who haven't experimented with Windows Store development yet, Windows Runtime or WinRT is essentially the way that you access the programming surface of Windows when you want to develop Windows Store applications. And I can tell you in .NET 4.5 we essentially have great support for writing .NET applications for the store. And here what you're seeing is a list of features or functionalities that were essentially missing from .NET 4.5 for writing store applications. Let me show you a couple of very brief demos, but the one thing I do want to point out is that all the goodness that we are adding for desktop applications such as WPF and Windows Forms, as well as web forms, these include event continue, the return value inspection features, and so on, are all supported for Windows Store application as well. So the expectation is your programming experience is going to be exactly the same as today. So regardless of whether you're doing desktop or you're doing web forms, when you do experiment or develop Windows Store applications, the experience will be very similar. Let me switch over and just show you briefly a couple of the experience that we have enabled in .NET 4.5. One when it comes to Windows Store development. One of the feedback points that we received is if you are building a store application and you want to basically convert a I/O stream to the stream type in Windows Store, which is the iRandom access stream, there is no easy way to do it. And so if you are essentially writing this code right here, which is basically get an image from the Bing wallpaper, trying to write this code is actually very hard today. Well, people are writing their own wrappers, and most of the time they have to deal with issues such as caching as well as concurrency. With .NET 4.5.1, it's a matter of, if I have an existing Windows 8 application, the first thing that I need to do is retarget it for Windows 8.1. This will basically upgrade your project. And then once I've done that, I can simply go ahead and change the application such that it makes it, I'm going to rebuild, and here there's a new method called as random access stream that now allows me to easily convert an existing .NET stream to a Windows Runtime stream. And then when I run this application, and I've got, you can see mad UI skills. That is one thing I'm not known for. And hopefully when I Bing it, this is a desktop wallpaper that I just downloaded from the web, and I'm displaying it right here. But the point is, it is much easier now to interoperate existing .NET code with Windows Runtime code. Another feature that if you are, for example, trying to use types or libraries that were written, let's say, in JavaScript or they were written in C++, it's now much easier to essentially consume those types and be able to debug them if you do see any issues. So one of the ones that I like to show off is here I have a Windows 8 application, and typically what would happen is when I run the application, any kind of exception information, these are things like the exception message, for example, or the stack trace would be lost. Well, in .NET 4.5.1, we've done work to make it now much easier to see exceptions that cross boundaries between existing, let's say C++ or JavaScript code into .NET code. So when I start this application right here, you will see full exception information that wasn't available in existing .NET 4.5. And in fact, this information would only be available to you if you've attached the debugger and we're looking at the things like the call stack window or the exception. So when you do start, I guess, your journey down the Windows Store development, hopefully these features will come in handy. And these are a couple of slides. As you said, it's a very common request out there that folks cannot convert existing I/O streams to iRandom access streams. And then here's the slide around not being able to propagate exception information from existing types in, let's say, C++, JavaScript to .NET. Another thing that I'm just going to quickly glance over is the fact that if you're writing a Windows application and wanted to have nullable value types in WinRT-struct, that is not possible today with .NET 4.5. So again, this is in my opinion, a productivity gain where you can now easily include those, especially as you're trying to do things like access database types that have a nullable field. I personally think this is one of the most wonderful new additions to .NET 4.5.1, and I hope when I show you the demo, you agree with me. So one of the things that's happened is as the world is shifting over to the cloud, such that your compute and your storage and your data, all of it that lives in the cloud, building applications that are resilient to connection problems is getting more and more difficult. You basically have to build a bunch of resiliency into your application and then make sure you've got all the corner cases covered. In .NET 4.5.1, we've added this feature that's also supported for EF called connection resiliency. And I think the best way to show you what this experience looks like is a before and after shot. And if I get this right, and hopefully I will, so I'm going to switch over to a 4.5 application, or earlier. And in fact, this is a 3.5 application on PC4. Yeah, I got that right. Perfect. And what we'll see here is the most mundane Windows Phone application ever written. Again, I am not known for my UI. So what I will do is I will control F5 to launch the application without debugging it. And you can see it's just a WinForm that talks to a database in the cloud. And what I can do is really exciting things like query for folks such as John, and I get a bunch of information back from John, and we'll do the same thing for, let's say, Jane, to make sure everything works right. Now, let's simulate a real-world scenario. Here, one of my favorite tools, TCP view. I'm sure many of you are familiar with sysinternal tools, and one of the best ones in my mind is TCP view. And what you can see here is the actual connection to my database. And what I'm going to do is I'm going to right-click on that connection. I'm going to drop it, right? So hopefully it's gone now. And what I will do is query for John again, and I hope you can expect what's going to happen. Right? This is the existing customer experience today. If you don't have connection resiliency, which is actually a hard problem built in your code, which includes lots of try-catches and retries and so forth. I'm now going to switch over to Visual Studio 2013 and .NET 4.5.1 and show you what the experience looks like in the new world. Let's open up this solution. Connect to my database. Notice it is the exact same application, and what I will do is just to simulate the same environment as you saw there. I'm going to have the TCP view open as well. I'm going to press Control F5, and you'll see the same thing. Let's just make sure it's working right. Query for John, query for Jane. Okay, report is exactly the same, and let's go and do the exact same thing to it as well. So I'm going to right-click on my connection and drop it. Okay, and let me just show you what this looks like now. I'm going to bring out my Windows Phone application right now, and notice what happens in TCP view when I type in John again. The connection is automatically reestablished without me having any retries or tries in my code. And so I think this is a great benefit by just upgrading your application to .NET 4.5.1, right? You notice I didn't have to change my application in any way, shape, or form. By simply running my app on a new framework, now I have this connection resiliency that's built in, which I think really makes the code that much more manageable, and also I think makes the user experience so much better for your customers when they're writing applications. As I said, you really don't have to do anything. It just works out of the box, right? So I would highly encourage you, if you don't believe my demo right here, if you have an existing application, if it's 3.5, it's just fine. Upgrade to 4.5.1, and then do the test that I just did and see what the experience difference looks like. Okay. Now that we've covered developer productivity and I showed you 5 different features that enhance that, let's talk about application performance. As I said, with application performance, one of our goals really is, by you hopefully doing zero work and upgrading to .NET 4.5.1, your app just gets better. And I'll try and prove 2 points here at least to hopefully make my case. So with the new release of Windows Server 2012 R2, I believe it's still in preview mode, which includes iOS 8.5, there's this new feature called ASP.NET App Suspension. And what it allows you to do is it basically allows low latency, high density websites for on-prem / private cloud. So the example that I would like to use today is, imagine you have a number of Windows servers on your corporate property. And you're hosting various websites on that. It might be your expense report, it might be your HR application, it might be your dashboard, whatever it might be. One of the things that happens is if the application doesn't get used very often, for example, and you have set it so that it times out or it terminates the ASP.NET Worker process after some idle time, the next time the user wants to go and use the application, there's this long delay, right, to try and bring up the application again. And so with this feature, what it allows us to do is, not only does it allow you to host more websites on the same server, but also the user experience for the customers that use those websites is dramatically improved. So in our very, very early tests, we've seen up to 7 times improvement in site density. That means being able to host 7 more times essentially websites on a single machine. The other thing that we've seen is, up to some instances, we've seen a 90% reduction in startup time, which, in my humble opinion, is a massive, massive, massive improvement, which, again, you'll get for free by simply upgrading your application. And so the way to achieve that is, in the advanced settings of iOS 8.5 in R2, there is this thing basically called idle timeout action, right? And you have 2 options. One is terminate, the other one is suspend. And so by setting it to suspend and then specifying what the timeout is, your application essentially gets sort of paged out to the disk, right? But in a what I call a ready state. So as soon as the website gets hit again, rather than having to re-spin up the ASP.NET Worker process and then be able to serve up the request, now you have this your app in a ready state sitting on the disk all along, and then it just works. And so what I'd like to show you is I'd like to show you a brief video of a recording that I did previously featuring .NET Nuke, which shows what the actual experience looks like. Let me go and switch over to AC3. Okay. And there is no sound here, but I'm going to actually just talk you through it. So here's what we're going to do. We're going to establish a baseline first. The way we're going to establish a baseline is essentially set it up so that one application starts from terminate, the other one starts from suspend. And as I mentioned, the way to do this is in the essentially iOS dashboard or management console. For advanced settings, for one application pool, we're going to set it to terminate, and you can see idle timeout action is terminate. And then we're going to set the idle timeout action for the second application pool to suspend. So it's a very, very, very easy setting to go and configure in iOS management console. And once we've done that, what I really want to do is basically set a baseline. We're going to recycle both application pools so that they're all in exactly the same state. And the way I want to do that is I want to show you that the experience to begin with is exactly the same. So what you'll see in a second is that we have 2 tabs. On the left tab is your terminate application pool. So we just hit the website. The experience was pretty snappy. And we hit the suspend now, and the experience you notice is very much the same. No difference at all. So from a terminate perspective, once they've been terminated, they start at the same time. Now we're going to do the next one right now, where the second page will actually start from a suspend. So this will start from a terminate, 1, 2, 3, and this starts from suspend. Instantaneous, right? Now, I'm going to do another test to show you the dramatic differences really this can make for your websites, right? We're going to time out again, but visit a different page, the register page on the .NET Nuke website. So go to register page. This is from terminate count. Okay, now let's do the exact same test from a suspended. Right? It is a big, big difference, and you can imagine for web applications that are more complex, where they load data and so forth, it can truly make a remarkable difference to the user experience. And as I said, the really nice things about that is that you didn't have to do any work, right? It's just simply basically upgrading your application and setting the IIS setting in the console. Okay, now I'm going to get really geeky with you. Can I see a show of hands? Who here tweaks the GC, the garbage collector? Do you do anything with the garbage collector in your application? Show of hands. I love that. There are very few of you. I can tell you the GC is one highly, highly, highly well-tuned machine. So I love the fact that folks aren't trying to tweak the GC to get the best performance out of it. And the reason why I mentioned that is we have noticed over and over again, despite the best intention of developers to wanting to fine-tune GC for the scenario, what typically happens is the well-oiled machine kind of gets out of tune very, very quickly to a point that suddenly the benefits of tweaking the GC, what I see by that is, let's say, causing an explicit collection on the GC, usually are outweighed by the problems that you run down the line. And what I mean by that is, this is this accumulative effect where, without you noticing it, your website, let's say, gets slower and slower, and you're wondering what is happening with my website. And there isn't a clear cause and effect in place to tell you, you know what, it was the GC that you were calling way up here that is now causing the application to essentially slow down. Now, the thing I'm going to show you is, I really would like to stress this out, with great power comes great responsibility. We've now added a feature to basically collect the large object heap. Now, for those of you who aren't familiar with how the GC is set up, I'm going to basically do a very 30-second description of why this is important. So the GC basically is segmented in different sections, and for objects that are essentially larger than 85,000 bytes, we have this special location. So we've seen customers that allocate ginormous arrays, right? And that's where those arrays will actually land, in this special spot on the heap as far as the garbage collector is concerned. And it's very, very expensive to compact. You can imagine once you allocate these very large objects, and the GC kicks in, there's a lot of moving around and compacting of the heap to basically move those objects around and make sure that you have additional memory. And therefore, what happens is, again, for those of you who are familiar of how the .NET GC works, it only happens on what we call generation 2, right? So you have your small objects that get collected on Gen 0, Gen 1, and then Gen 2 is for the large objects. And now, in .NET 4.5.1, since we've received a bunch of feedback for folks who really, really need it, you can actually collect the large object heap. And there are two ways that you can do it. We typically refer to it in-house as LOH. That's how we refer to it as the large object heap. The first one is compact right away. I want you to basically spend some time compacting the heap, and I'm going to show you through a demo. This is an expensive operation, so please, 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 if you feel like you have essentially heap fragmentation issue as far as a large object heap is concerned, you have to be very cautious of how you use this feature. Or you can basically say, you know what, mark the large object heap so that when you run the next collection, collect it there, but don't do it right now. And so let me show you what that experience looks like by a very, very simple demo. I'm going to close a couple of these so it's easier for everyone to see what is actually going on. Okay, I have a very, very simple console application here. Let me see if I can find the LH. Okay, and what I'm going to do is to demonstrate what this looks like. Bring up the command prompt, go to where the demos live. Wait. Okay, so we're just going to run this demo right now, and what'll happen is, actually, I'll let the demo explain itself. The application, what it does is it allocates a very large arrays on the heap through iterating this loop that basically does 8,000 iterations per inner loop, and then there's the outer loop that allocates these arrays. And so what you saw is the heap reached around, what is that, 1 gig after about 50,000 iterations, and then it basically broke. And what I mean by broke is that the experience you'll see in your application is that you get a or an out-of-memory exception, right? And trying to debug out-of-memory exceptions is a very, very, very hard thing to do. It's because trying to figure out how the objects are being allocated, there are some very, very special tools that we have. One of them is called SOS, for example, that use WinDBG and more advanced tools to figure out what's the allocation of my heap. And there's a lot of pointer chasing, essentially. And so what I'm going to do right now is run the exact same test but pass in the compact flag. And this will then, notice what happened. We tried to allocate. There was not enough room on the heap, and basically we did a GC, collected, and it can take many, many, many seconds, sometimes minutes, for the GC to basically compact a large object heap. So that's why I really do want to stress, with great power comes great responsibility. Now, one of the beautiful things, of course, is that your application won't crash, right? But at the same time, you can imagine if this was now a website, right? As the runtime is sitting there trying to do the collection of the heap, users are just literally blocked, right? They see the spinning circle, or they see a 404 because your ASP.NET working process just cannot service their request in time. But if you have very specific requirements for your application, then now there is a way to essentially get through that glass ceiling so that it does work. And I can just let this run furthermore, and you won't see an out of memory exception. Yeah. Okay, I'm just going to leave you with one thing on this slide. If you really believe you have a heap fragmentation issue with your GC, something referred to as a ginormous GC fragmenter syndrome, I actually, this is honest truth, we have one of the world's most amazing senior developers that her specialty is the GC and the GC. She knows the thing inside out. And in fact, when I was spoken to her, she said, if any of developers or customers have issues with the GC, please let them email me and tell me what their scenario is. And that is how adamant, I guess, I am when I say, I really hope that when you do think about tweaking the GC, you've thought about all the other ways that you could optimize your application. We've seen lots of problems that are actually architectural issues, but folks trying to essentially kind of paper over it by tweaking the GC. But if you really have a real-world scenario, we would love to hear from you. when it comes to heap fragmentation.